For topic four, we're not really going to go deep into this, but one thing you do need to look out for when you're dealing with statistics is deceptions in visual display. And since we've learned two ways to visually display our data, we need to make sure we're not using any kind of deception. Okay. So the first thing you always need to do is make sure there is a title so that you can understand what your display is referring to. So that is one area that I would say we were weak in this worksheet. We should have had titles here. Okay. So we should have titled our graphs. Okay. Now we sort of had titles. Okay. We had a general idea what was going on, but for the stem and leaf plots, we really didn't have any kind of titles. But down here for the histograms, we knew we were talking about the age of maximum growth. You could kind of get an idea of what was going on from the labels on the X and Y axis. Same thing for the test scores, the final grades, and then again the exam scores. Okay, but you want to make sure you tell your reader what your visual display is all about. Okay, and then our numbers lined up with tick marks on the vertical axis that clearly indicate the scale. Has the scale been varied to create more or less dramatic impressions than shown by the actual data? So in ours, we had consistent tick marks. What would be really deceptive is if we went 2, 4, 500. Okay, you had some like big jump to where you didn't have equal intervals, and that can sometimes create a lot of misleading understanding from your visual display. Okay, so you want to make sure as you label your X and Y axis, you also put tick marks that are consistent. Okay, you can't have weird jumps and inconsistencies because that can lead to misleading understanding of what's going on. Okay. Do too many design and cosmetic effects draw attention from or distract from or distort the data? Sometimes you'll have these tables and charts and graphs that are just so flashy, but at the heart and soul of it, you're like, what in the world is this thing even about? And sometimes that can be done very much intentionally, like, hey, if we can distract our reader from what the table actually says, they won't be so caught up in what the table actually says. So, a little bit of cosmetic work on your table is fine, but you don't want to get too extreme to the point where the cosmetics, the design features take away from the actual data in your table or your graph. Okay. Has the wrong impression been created about how the data are changing because unequally spaced time intervals are not used on the horizontal axis? So, just like with the frequency distribution here, we kept our intervals very consistent. So we went from the 40s to the 50s to the 60s to the 70s to the 80s to the 90s on the x-axis, and then we incremented by twos from 0 to 20 on the y-axis. You want to make sure everything is very consistent because you can accidentally give off seriously misleading information about your table if things are not incremented the same. Okay, for example, I could have something where I'm comparing two things, and I might have a table that's like this. Let's say we're talking about the price of a computer. Okay. So let's say we have store A, store B, price of computer. You can call it whatever computer you want. And let's say A, we have $1,100. So we're saying, hey, this is the price of the computer at store A. And then store B, we have it right here. So it looks like the computer at store B isn't really that much more expensive, but in reality, it's like 5 times more, okay? Because we have an inconsistent jump here, okay? So if you have this much height for 1100 and only this much to represent the remaining up to 5000, that's really inconsistent. It doesn't show how much more expensive the computer is at store B compared to store A. So you have to make sure you have these consistent intervals so as not to mislead your reader. And a lot of times, again, this is done sometimes intentionally. They'll do things if you want the reader to take something away that's maybe not accurate, you can mislead the reader with how you increment your X and Y axis or how you label a graph or what kind of bells and whistles you have on your graph. Okay. Part five, are the bar sizes scaled proportionally in terms of the data they represent? A good example of that is this picture I have down here with the dollars. you can see here we're talking about the value of the dollar over time, okay? And they're saying in 1980, let's say the dollar was worth a dollar. By 1990, it was only worth 63 cents. By 2005, it was worth 43 cents. But you can see they scaled things kind of wacky along the y-axis, so you're not getting a true understanding of the value of the dollar, okay? And then six, is there a source that indicates where the data came from? Does the title indicate population or sample or random sample, etc.? So when you do have information like this, if you are dealing with information from the population, it is worth saying you're dealing with information from the population versus information from a sample, because remember, we already know that you can skew your data based on who your sample is. So you need to tell us who your sample is so that we can make our own interpretations out of that. We also need to know that the data is legitimate. So like a lot of the data I pull from these tables, it's like just fake made up data. Okay, but if you do pull data from like a real source, you need to indicate where your data came from, like kind of give credit where credit is due. But also, if you're getting your data from some just Joe Blow website that some kid made on the weekends versus a real like government website, you're going to have two different sets of data in that case. One is believable, the other is who knows. Okay. So make sure you have properly labeled everything in your graph. Make sure you don't have any kind of distractions in your graph that takes away from the actual data. Make sure your data is properly sourced. Make sure your data comes from a reliable source. Increment your graphs properly. Look for these things that can cause misinterpretation of results. Okay, so in this graph down here, the purchasing power of the diminishing dollar, they've made it a little dramatic. Okay, so they have this giant dollar in 1980, which lets you believe that the purchasing power of a dollar was this big in 1980, whereas in 2005 it was this big. Yes, the purchasing power of the dollar has changed, but the visual makes it so much more dramatic. Okay, so just be on the lookout for things that can mislead your reader. Okay, so that is that. We have talked about collecting and organizing data. In the sections that are to come, we will talk about analyzing and interpreting data.